This next section would still be without a calculator. Write a sine and a cosine equation to model each of these sinusoidal functions. So the first thing I like to pick out is the midline in the graph. And sometimes you can kind of just see what it is, but also remember you can calculate it. So it's the average of the max and the min. So add the max, which is 4, to the min, which is 0, divide by 2, and you get 2 that way. Although this one, like I said, is pretty easy to visualize. I also like to draw it in. So it's the midline is 2, and that's the D value when you're building these equations. The other good thing about drawing in the midline is it's easier to see the amplitude. The amplitude is from 2 to 4, so the amplitude is 2. The period is how long it takes to complete one full sine or cosine curve. So I'm seeing a sine curve to begin with that spans from 0 to 6. So the period is 6, and we set that equal to 2 pi over b and solve for b. So 2 pi divided by 6 is pi over 3 for the b value. And then for the phase shift, remember there's two versions of this. There's a sine version and a cosine version. So the sine version has not been shifted. C equals 0. This starts right on the y-axis. But the cosine version would have to get shifted. So remember, there are multiple ways to begin or places to start. So I'm just looking at the cosine curve that starts here, ends here. So I've got to figure out where that is. So if this is 2, this is 1, and this is 1.5. So the cosine curve has been shifted to the right, so minus 1.5. And once you have A, B, C, and D, you have enough to write the equations. So starting with the sine curve, y equals, this is a positive sine curve because it opens up from the midline. So positive 2 sine of b, which is pi over 3, times, I'm going to write x minus 0. And the midline is 2, so plus 2. And then for the cosine curve, the cosine curve that I marked off is also positive. It starts above the midline. So y equals 2 cosine pi over 3 times x minus 1.5 plus 2. Okay. If you got a different equation, type my equation, one of my equations in Desmos, type your equation in Desmos, and if they line up, then you found another equation that's just as correct as the two that I have. Okay, for this one, midline looks to be 0. We can kind of verify that. Let's see, this is at a height of 1. This is at a height of -1. So yes, the midline is 0. So that's the D value. Actually, I don't really need it to be Y. So D is 0. The amplitude, I just said max and min are 1. So the amplitude's 1 for A. The period, let's see, how far from, let's just mark off here, from this low point until we get back to a low point again. So from -1 to 7, the period is 8. Set that equal to 2 pi over b and solve for b. So 2 pi divided by 8 is pi over 4. Phase shift, there's been a phase shift no matter what version you pick. So let's go with cosine to begin with. If my cosine curve starts here instead of on the y-axis, that's been shifted to the left, so plus 1 unit. And if I'm looking at a sine curve, I've got to pick out a section of sine here. Again, you've got freedom to pick wherever you want. I'm going to start here and then go up. So the rest of my sine curve's off the graph. That doesn't matter. This is 1 unit to the right. So if it's a sine curve, I'm going to say C is -1. All right, so starting with the cosine curve this time, this is a negative cosine curve. It's starting below the midline. So y equals negative, I'm not going to write 1, but just negative cosine of pi over 4 times x plus 1. And then d is 0. I'll just say plus 0. For the sine curve, it's y equals, this is a positive sine curve again. So positive sine of pi over 4 times x minus 1 plus 0. Again, if you got something different, if you picked a different section, just check your equation with mine in Desmos. And our last type of problem, we've had this a few times now. This one, I can see where one period is, but I can't see exactly how many units that is. It's not marked off. So when that's the case, you've got to see how many periods fit within whatever unit is marked off. So here's 1 period, 2 periods, 3 periods. So we get, that's a frequency. We get 3 periods in 2 units from 0 to 2. So 3 over 2 is the frequency. That means that the period is 2/3. And if I set that equal to 2 pi over b, when I solve for b, 2 pi divided by 2/3 is like times 3/2. So b is 3 pi. Okay, so b is 3 pi. Midline, what is the midline? So I can visualize it here, or I can say there's a max at 1. I add to that the minimum -3, and I divide by 2. So that also gives me -1 for the midline. And then if you draw in the midline, it's easier to see that the amplitude then is 2 again. A is 2. And as far as a phase shift, if this is a cosine graph, there's no phase shift because this is starting right on the y-axis. If I look at a sine graph, and maybe you go back here, or I'm going to go right here, I think. Where does this sine graph start? So remember, the period is 2/3, and this value is 1/4 of the period, right? So let's look at from cosine. Cosine goes from 0 to 2/3. That's its period, right? And this value is 1/4 of 2/3. So that becomes 1/2 times 1/3. So that becomes 1/6. So this point from 0, it's 0 plus 1/6. So the sine curve is has a c value, of -1/6. So yeah, the period is always, for any, you've got a cosine curve. If you divvy up the period into 4 equal parts, that tells you, like, this is 1/4 of the graph, this is 1/4 of the graph, this is 1/4 of the graph, and then the period is 1/4. So whatever the period is, this first point is 1/4 of the period away from whatever this point is. Okay, what about the equations? Let's start with cosine. Y equals, it's a positive cosine graph, so 2 cosine of 3 pi times x minus 0 minus 1. And for the sine curve, y equals, this is a blue part is a negative sine curve, so -2 sine of 3 pi x minus 1/6 minus 1. All right, the next part would be the only calculator section that we have. So same thing we've been doing, write both a sine model and a cosine model for each situation. A mass is suspended from a spring 6 feet above the ground at rest. So I'm just going to give myself a generic midline. This is not 0, this is just the midline. If the spring is at rest, though, that is the midline, right? So anytime the spring is at rest, that's the midline. So we actually know midline is 6 feet above the ground. The spring is pulled down so that the mass is now 4 feet above the ground and then released at time equals 2. So we pull the spring down, so it's now 4 feet above the ground. And then so here's the first point, and then we release the spring. So it's going to bounce back up, come up above midline, midline below. Now, if this is a distance of 2, this is a distance of 2. So I know the max is at 8. And we've got a nice little cosine curve here. Let's see. So we did that, released at 0. The mass oscillates. The mass returns to its starting position after 2 seconds. So its starting position was down here. That's the period. The period is equal to 2. And that's equal to 2 pi over b. So we solve for b. 2 pi divided by 2 is pi. So we've got a value for b. We also have a value for a. We can see a. It's 2 and we can see the midline is 6. So the only thing left is the phase shift. So for cosine, the phase shift is c equals 0. There is no phase shift. For sine, the sine graph I would start here and kind of finish over here. So this point, remember, is always 1/4 of the period, and the period is 2. So that point is at 1/2. That makes sense. That's 1/2. That's 1. That's 1.5. That's 2. So the c is to the right 1/2 unit. So the model I'm going to write for cosine is y equals -2 cosine of pi times x minus t minus 0. They didn't tell me that I had to call it something other than y, but you don't want to use x because we were given t as the input. And then plus 6. And the sine function is y equals +2 sine of pi times t minus 1/2 plus 6. And then this also says, so write both models. We did that. Determine the height of the mass above the ground at 1.7 seconds. You should be able to plug into either one of these two equations. It doesn't matter. But you're finding t of 1.7, which means put 1.7 in for that t. So make sure that your calculator is in radian mode. I will remind you of that on test day. I'm not going to have to switch modes on this one. I'm just going to use the sine equation. You should be typing this in exactly as you see it, except replace the t with a 1.7. So 4.824. If you have extra time on your test, check this in the other model, and if you get the same answer, that's a pretty good indication that you have the correct equations for both of those. And the label on this is feet. So models and answer right there. Okay, Ferris wheel problem. We've had a few of these now with a wheel. So if I have a wheel, I'm going to draw the wheel if it's not already given to me, or a circle or whatever. So there it is. And then right next to that, I'm going to put my midline for my sine and cosine graph. As you ride a Ferris wheel, your distance from the ground varies sinusoidally with time. When the ride starts, your seat is at the top of the Ferris wheel, 43 feet above the ground. So here we are, 43 feet above the ground. The diameter of the wheel is 40 feet. So this is 43. If I go down 40, so that means that this low part is 3, and then halfway between is 23, right? Diameter, radius would be 20 if the diameter is 40. And so we have all that stuff labeled, so that's good. And we make one revolution every 8 seconds. So you start at the top of the wheel. It doesn't really matter which way it's spinning. You go down. If you're at the top, it doesn't matter. You go down from there to midline. Then you'll hit the low point, midline, and back up. That one revolution happens in 8 seconds. All kinds of information here. We have the midline is 23. The amplitude is 20. The period is 8, which I set equal to 2 pi over b. So b is pi over 4. And then the last thing to figure out is the phase shift. So this point here is 1/4 of the period. So that's at 2. That makes sense. That's 2, that's 4, that's 6, that's 8. You don't have to label all of them, but it kind of checks out. Okay, so if we have, for phase shift, if we have a cosine curve, c is 0. If we have a sine curve, then c is -2. So when I write my models, the first one is going to be y equals 20 cosine pi over 4 t minus 0 plus 23. And if I want to write the sine curve, it's going to be y equals, the sine curve opens down and would come back around. So -20 sine of pi over 4 times t minus 2 plus 23. This question says, write both models. Did that. Determine your height above the ground if you've been stuck on the ride for 10 minutes. So remember, these times are in seconds. So time is in seconds here. So change 10 minutes to 600 seconds, 60 times 10. And then again, it doesn't matter which model you plug into. It might be smart to plug into your non-shifted model in case you made a mistake on what that value was. So 20 cosine of pi over, my pen stopped working, just a minute. So 20 cosine, there we go, of pi over 4 times 600. You don't have to do the minus 0, I will. And then plus 23. So we get 43. I guess we'll be at 43. I thought I got a different answer when I plugged that in last time. I'll have to check on this again. So I got that the height is 43 feet after 10 minutes. Let me see. Let me see what I got on my other key that I posted. I got 40 when I did that. Oh, whoops, because I only have plus 20. That should be plus 23. Okay, this is right. You're at 43. Sorry about that. So that's fine. So you're at 43 feet after 10 minutes. You're back to the top after 10 minutes. All right. Last one of these. A water wheel rotates 6 revolutions per minute. Now, that is not the period, that's the frequency. So if the frequency that's the number of revolutions in 1 minute, 6 revolutions in 1 minute. Pay attention to what t is, whether it's minutes or seconds. So this says 2 seconds after you start a stopwatch. So I need to change this right now. That's 6 revolutions in 60 seconds. So the frequency is 1/10. That makes the period equal to 10. And then the period is 2 pi over b. B is 2 pi over 10, so pi over 5. And then what about everything else? Let's see. 2 seconds after you start a stopwatch, point P on the rim of the wheel is at its greatest height, 13 feet above the surface of the water. So let's get a midline and a vertical axis here. So we now know that this is 13. That happens at t equals 2. Now I can complete the rest of the graph right now. I can say midline, because that's the highest point, right? So no matter which way this wheel is rotating, it hits midline, below midline, midline, and back above. Okay, so let's see. The center of the water wheel is 6 feet above the surface. So here's the center of the water wheel at the midline. This is 6 feet. Now be careful though, because the water wheel, this point on the water wheel, it is going to go below the water as well. The bottom of the water wheel is 1 foot below the surface of the water. Okay, so that means that, think of the water level as 0. That means that the lowest point we hit right here, oh, I didn't, hold on. Let me line it up correctly with my graph here. So lowest point should have really been down here. So the lowest point that I hit on the graph is not at 0. It's 1 foot below 0, so it's at -1. Okay, and then we've got a distance of 7 for A, but this height here, we're at 6, we're at 6 feet above the water level, right? Because here's 0. Okay, that checks out. There's 7 units above 6 and 7 units below 6, so that is correct. So our midline is 6, our amplitude is 7, and we have a cosine curve already graphed. For the phase shift, if it's cosine, we're to the right 2 units, so -2. We have the period, right? The period was 10. So if the period is 10, this point right here has been shifted. It's a fourth of the period away from this point that's at 2. So it's 2 plus a fourth of the period 10. 1/4 of 10, well, half of 10 is 5. Half of that is 2.5. So 2 plus 2.5 is 4.5. All right, so if we're looking at a sine graph, then we're shifting to the right 4.5. And we want to draw the write the model. So y is equal to, for the cosine graph, it's 7 cosine of pi over 5 times t minus 2 plus 6. And if we're looking at sine graph would start here and open down. So it's negative 7 sine of pi over 5 times t minus 4.5 plus 6. This question says, write a cosine model. I guess I did more work than I needed to. Write a cosine model and determine the first time after 2 seconds that the point will be 8.5 feet above the surface of the water. Even if I didn't tell you to write the cosine model, you would need to use that to find the first time, because, okay, mark off where 8.5 is-ish, right here. Which curve are you on when you hit 8.5 for the first time after 2? You're on the cosine curve. You haven't hit your sine model yet. So you can't use the sine curve for this one. You have to use cosine. So y will equal 8.5, and I need to use my calculator for this. Now, when you're doing the calculator, you've got the window set already. You're not guessing at the window. It's right here. So type your equations into y equals. So this one's going to be 7 cosine of pi over 5 times x minus 2, parentheses, plus 6. And then this number is going to be 8.5. Change the window so that the x's go from, they need to go 0 to 12. And the y's should go negative 1 to 13. Press graph. And remember, we're not looking for this point. We want the first point after 2 seconds. So match your graph. You want this point right here. So second, calc, intersect. Make sure the cursor is closest to that intersection point. So enter, enter, enter. 3.919. So this is when t is about equal to 3.919 seconds, which is a good sign because we were looking for the first time after 2 seconds. So I know I found something right because I was at least after 2 seconds. I'm going to stop this video here. The last part of the review is back to non-calculator, and we're just evaluating inverse trig.